Okay, so this is a part that you can have a calculator with, but remember when it says exact answer, they're not going to want a decimal, so make sure you pay attention to that, just like we've been doing all year. So again, a lot of this is just formulas, so maybe writing those formulas out would be a good thing to do. I'm still sick, my voice is still struggling, so just bear with me. But arc length is S equals R theta. But remember that theta has to be in radians. So when you do this, R would be half of 72, which is 36. And then you have to change that to pi over 180. And then you can use your calculator to simplify this. It's kind of up to you. But it actually works out really nice because 18 goes into 36 two times. So it works out really nice to be 16 pi. But if it's a fraction, that's okay too. Just type it in your calculator without pi, and it should give you the answer. Area of a sector is 1/2 r squared theta. Again, where theta is in radians. So r is still 36. And our theta here was what? 8 pi over 18, which is the same as 4 pi over 9. And then I would just use my calculator there without putting pi in it, and you should get 288 pi. Number 12 says at the top of Gorsline Tower, when the top of Gorsline Tower is viewed at a distance of 215 from the base, so here's my tower, and it's viewed 215 feet from the base, the angle of elevation, remember angle of elevation is from the ground looking up, so that means this is 41.7 degrees, and I want to know the height of the tower, so that would be opposite over adjacent, so that would be tangent of 41.7 degrees equals h over 215. Make sure your calculator is in degree mode when you're doing this, right? So be careful. But I would just take on my calculator and take 215 times the tangent of 41.7 degrees. And it does say round to the nearest tenth. So I got 191.6 feet as my answer. So that's just SOHCAHTOA, right triangle trig, right? Number 13 says use the law of sines to approximate the length of side A. So law of sines, because they give me this, right? If I labeled this A, B, and C, B is 44, C is 96, which means I could find angle A by just subtracting from 180, which was would be 40 degrees. So this is 40. And they give me side B is 32.5. And they want me to find side A. So that's A over sine of 40 equals 32.5 over sine of 44. And again, I just do that all on my calculator at once. I type this in and I multiply by sine of 40 all at the same time so that I don't have to get anything else. If it said solve the triangle, we really already found the missing angle and one missing side. You could also solve for side C doing the same thing if you really wanted to. Question 14, law of cosines. Remember law of cosines, you can use that when you can't use law of sines. And so this one says of side C, and very nicely they give us angle C. So that means we can say C squared equals A squared plus B squared minus 2 times A times B times the cosine of the angle. And then actually to solve for C, I'm just going to take the square root of all of that, right? And again, I'm going to do that all at once on my calculator. And if I did that all at once on my calculator, let me turn the page because I did this already. I got 110.8. And again, that would be the third side of the triangle, and then you could go backwards and solve for your angles as well. On this one, because angle that they gave us is obtuse, you can't have more than one obtuse angle in your triangle, so you don't even have to worry about angle side side. Number 15, this goes back to more of the beginning stuff that we did. This is a quadratic, kind of like U substitution, where you can factor this, or you can do the quadratic formula. I factored it because I just noticed that it was factorable of like what multiplies to give me 12 that adds to give me -7. So I wrote this as -4 sine of x minus 3 sine of x plus 1. And I did that factor by grouping, where I factored out a 4 sine of x, and I was left with 3 sine of x minus 1. And over here, I'd factor out a -1 to get 3 sine of x minus 1. So then that factors into 4 sine of x minus 1 times 3 sine of x minus 1. Right? That's one way to do this, is factoring. And then I set each one equal to 0. So I get sine of x equals 1/4 and sine of x equals 1/3. If you're not a factoring person, the other thing you could do is you could do the quadratic formula. So let me show you that really quick. Oh, it just made a noise. I hope that didn't mess my voice up. If I do the quadratic formula, then if not what x equals, it would be that sine of x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And that would be 49 minus 48, which would be 1. So you get 7 plus 1, which is 8 over 24, and 7 minus 1, which is 6 over 24. So you still get the same answers. You get sine of x equals 1/3, and sine of x equals 1/4. So either way you do that, you get those same answers. So factor or the quadratic formula. That's step 1. Step 2 on this problem is solving for x. This says degrees, so my calculator would be in degree mode, and I would do inverse sine. And when I do inverse sine of 1/3 in the calculator, I got 19.5 degrees. And when I did inverse sine on my calculator for 1/4, I got 14.5 degrees, which makes sense because sine is positive in quadrant 1. But remember, this is where your calculator only gives you one answer. So we're in quadrant 1. And remember that sine is also positive in quadrant 2. So there's actually 4 answers to this. And to get those other 2 answers, we need to take 180 minus each one of those to get that second angle. So that would be 160.5 degrees and 165.5 degrees. So remember, your calculator gives you one answer, and then your brain has to give you the other answer. Number 16 is sum of cosine. And so this is, again, just a formula that cosine of a plus b is cosine of alpha times cosine of beta minus sine of alpha sine of beta. Maybe not a bad idea to review both your sine and cosine sum and difference ones. And then this is where you have to draw a triangle. So it says that they're both in the first quadrant. And so cosine is 5 over 7. So I can do Pythagorean theorem to get that this is the square root of 24, which would be 2 square root of 6. And then, so that's alpha. And then beta, oh wait, it says that's beta is a second quadrant angle, and so that would be -8 over 13, and I can do Pythagorean theorem, and I got the square root of 105. So then I just do that. Cosine of alpha is 5 over 7. Cosine of beta is -8 over 13, minus sine of alpha is 2 square root of 6 over 7. And sine of beta would be square root 105 over 13. So I get negative 40 minus 2 times the square root of 630 over 91. And then I think we actually could break up that 630, right? 630 divided by 9 is 70. So that would really be like 9 and 70. So I think it would be better to say negative 40 minus 6 square root of 70 all over 91 would be the exact answer. Um, 17 is another formula. Sine of 2 theta equals 2 sine of theta cosine of theta. And so again, if they give you information, 180 and 270 is a quadrant 3. Secant is hypotenuse over adjacent. So you know that that is how you do your triangle. You do a Pythagorean theorem and you get square root of 561, but because it's in quadrant 3, that's how I know it's negative. So then I just use the formula. So the sine would be negative square root of 561 over 25, and cosine is negative 8 over 25. The negatives cancel out, and I just multiply the top. 8 times 2 is 16, square root 561, and 25 times 25 is 625. Not a pretty answer. 18 is most recent thing that we've done. This is an ellipse because it's addition. The y is the bigger number. So if I make some lines on here, let's change colors here. The center is h and k, so that would be 6, negative 1. 1, 2, 3, 4, 5, 6, negative 1. It says labeling, so I'm going to put C for center. The number under X goes left and right, so I would go left and right, 3, which actually means I would go out here, 3. I would go up and down 5, 1, 2, 3, 4, 5. That would be a vertex, and down 1, 2, 3, 4, 5. That would be a vertex. And I would draw in my ellipse. And then the foci is C, so I would have to find that. So that's 25 minus 9 equals C squared. That's just 16 equals C squared. So C equals 4. So my foci would just be 4, 1, 2, 3, 4. That would be a foci, and down 1, 2, 3, 4. That would be a foci. Okay? '19 says, find an equation of a hyperbola that has a center at the origin and satisfies the given conditions. So since these are moving on the y, we know it's y minus k squared over a squared minus x minus h squared over b squared equals 1. And it actually says it's at the origin, so it's h and k are just 0, right? So it's just y squared minus x squared equals 1. If the vertices are plus or minus 5, that means a equals 5. So that means 25 here. And that means that C equals 40 from the foci. So I'm going to take 40 squared minus 5 squared to equal B squared. And I got 1575 for that, which seems really big. 1575. Almost done here. 21 is just a formula, Heron's formula, that says to find the area, you take the square root of S times S minus A times S minus B times S minus C, where S equals A plus B plus C divided by 2. So for me, on this one, I got that to be 35. So I just used my calculator, and I took the square root of 35 times 35 minus 29 times 35 minus 18 times 35 minus 23. And in my calculator, I got 206.98, but if I'm rounding to the nearest tenth, that would round up to 207. So I really got 206.98. but rounding to the nearest tenth, I got about 207 square feet. And then the last one says, given triangle A, B, C, B is 150 feet, C is 71 feet, and angle A is 29 degrees. To solve for both the side A and B. So side A, we don't have enough information to use law of sine, so this is a law of cosine one. So I said A equals the square root of 71 squared plus 150 squared minus 2 times 71 times 150 times cosine of 29 degrees. And I did that on my calculator, and I got 94.4 feet. But to solve for angle B, we don't know, like 150 is bigger than 71, which means that, and also bigger than 94, which means 150 is the biggest side of this triangle. So if it's an obtuse angle, law of sines is not going to give me that answer. So this is where you have two options. One option is you could solve for angle C first and then subtract from 180 to get this. The other option is you could use law of cosines to solve for angle B. But if you do law of sines to solve for angle B right now, it's going to give you the wrong answer. So you have to be really careful when you're doing that. For me, I did C first. So I said, well, I'm going to solve for the shorter side first. So I did sine of C over 71 equals sine of 29 over the answer I just got, 94.4. And that means I multiplied by 71, and then I did inverse sine on my calculator, and I got 21.4 degrees for angle C. And then I subtracted from 180 to get angle B, which is 129.6 degrees. So this is an example where you can't just go back to law of sines all the time if it's the biggest angle you're solving for. The one thing that's not on here that I know is on your test is the one like this. It says find the equation of a circle given the endpoints of a diameter. We had one like this on our Unit 4 packet, our Unit 4 exploration. So Unit 4 exploration, Unit 4. We had one on our quiz, number 10. And we also had one like this on our Unit 4 test, where you have to do the distance formula and the midpoint formula. So that's another one that I want you to look over, okay?